So today we're going to be talking about our Chapter 6 review. And so we're going to do this like we do in class, where we break it up, where you get an opportunity to try each problem. And then after you're done trying it, then we're going to go over the actual work and the correct answer. Okay, so today is going to be part 1. So it's going to be questions 1 through 10. And then tomorrow will be 11 through 20. And then if you have any issues or any problems, you can bring those questions to our Zoom session on Thursday. It'll be a Q&A before the test on Friday. Okay, so question number 1 was to find the inverse of 3 plus 5x. So this was a step-by-step process, and we said the first step was to rewrite using x's and y's. Okay, so I have it as y equals 3 plus 5x. Now step 2 was to switch the location of x and y. So for us now, it's now going to be 3 plus 5y is equal to x. And then our job was to actually solve it for that y right there. So the first thing I have to do is I have to move the 3. That way they cancel here on the right. And on the left, I'm left with x minus 3 equaling 5y. Now, if I want y by itself, my last step is I'm going to divide by 5. I divide both sides by 5, and I get y is equal to x minus 3 over 5. And we used a different notation. We used f of x to symbolize our inverse function. And so I'm going to do that. Okay. And so instead of y, we write it as f inverse of x is equal to x minus 3 over 5. So the correct answer would be C for this one. So hopefully you got that one right. All right. Question number 2. It says use the area of a circle whose radius is 3 x to the 3/4 z to the 5 inches to find the area, and we use 3.14 for pi. So what I'm going to do is, in case you have forgotten, the area of a circle is pi times our radius squared. So we have to replace our r with 3x to the 3/4 z to the 5th. So I'm going to rewrite it as pi times 3 x to the 3/4 z to the 5th squared, right? And so the pi is on the outside, so we leave that alone. Okay, we're going to leave that alone. But we do have to distribute the square to everything else. And so I'll write it down here. I'd say pi times 3 squared is 9 times x to the, 3/4 times 2 is going to be 6/4. Okay, I'll write it as 6/4. And then z to the 5 times 2 is 10. Now, I'm not entirely done because you'll notice that's not an option there for A, B, and C. So one thing I have to do is I have to figure out what pi times 9 is. So I go to Desmos, okay, and I do 9 times 3.14 because they tell us that's what pi is. It's 28.26. So I go back here and I know that it's going to be 28.26. 6/4 actually reduces to 3/2, and z to the 10th is still there. So which one of these is our correct answer? The correct answer is going to be A, 28.26 x to the 3/2 z to the 10th. Again, hopefully you got that one right. Now, number 3. It says the approximate time t in seconds it takes an object to fall a distance of d feet is given by t equals the square root of d over 16. So we're asked to find how far an object will fall in 8 seconds. So obviously we know that 8 seconds is our time, right? So we're going to rewrite this problem as 8, and I won't use seconds, is equal to the square root of d over 16. And you see that we have our unknown value is going to be d. That's what we're solving for. So if I want to get d by itself, I have to first start by undoing this square root. So the opposite of square root is square, right? So the square and square root are going to cancel, okay? And I end up getting, 8 squared is 64 is equal to d over 16. So we have to solve it for the value of d, our distance. So what we're going to do is we're going to undo 16. So I multiply both sides by 16 so that they cancel out. And I find that my distance is equal to 16 times 64. So I will do 16 times 64. That's 1,024. So D is 1,024, and then I guess our distance is feet. So that would be C for number 3. Okay, let's try number 4. It says if x is a positive number, okay, so that's kind of beneficial in the fact that we know that we have a square root and we can't have negatives under even squares, right, or even radicals. So it says if x is a positive number, then the square root of x to the 5th divided by x to the negative 5 halves equals what? So I'm just going to start by rewriting this, okay? And so the square root of 5 would be 5 halves, right? Divided by x to the negative 5 halves, right? And there was a rule that we learned back when we were talking about radicals, and we used it in this section as well, is anytime we're dividing two numbers with the same base, we subtract our exponents. So 5 halves minus a negative 5 halves. Now, normally we'd have to make sure that we have a common denominator. We're lucky that we both have a common denominator of 2. So I'm going to subtract a negative or add, and then 5 plus 5 would be x to the 10 halves. And obviously, 10 halves. And so obviously you can tell that 10 divided by 2 is going to be x to the 5th. So number 4 is C, x to the 5th. Okay. Number 5, which inequality is graphed below? So there's a couple things that we can look at first. The first thing we look at is this a solid or dotted line? And I see that it's dotted, which means that I'm going to be using less than or greater than symbols. Remember, solid lines were less than or equal to or greater than or equal to. So automatically I can get rid of A and I can get rid of B. I know that it's less than or it's a greater than symbol. Then we talked about, is it shaded above or below? Well, this is shaded above, which means we're going to use greater than. So our correct answer is D. Now let's say you're not quite sure and you want to check your answer. That's perfectly fine. What we can do is we can pick some values, or we can pick a point in the shaded region to make sure that it still works. Now, an easy one that we can pick is we can use, let's see, 0, 1, 2, 3, 4, 5. Let's use 0, 6. It's right at the top, right about there. That's the point 0, 6. Okay? And so what we're going to do is we're going to plug in 0 for x and 6 for y in that inequality we just found and see what happens. Okay, so y, or 6, has to be greater than the square root of 0 plus 3. Okay, and so what we're going to do is 6 is greater than 0 plus 3 is just the square root of 3. So I'm not sure what the square root of 3 is, so I can go to Desmos and I say, okay, well, what is the square root of 3? It's 1.73. And so we say, is 6 greater than 1.73? It is. So we know for sure we are correct with D. Okay? Now, number 6 says to simplify that third root. Okay? All right. So what we're going to do is we are going to look at this and we're going to say, okay, I'm going to start by rewriting it in exponential form. So 256 t to the 4th, all that to the 1/3 power. Now I have to give that 1/3 power to both 256 and to 4. So I'd write it as 256 to the 1/3 power and t to the 4/3 power. Okay. Now 256 to the 1/3 power. Let's look at what that is. Okay. So 256 to the power of 1/3 is a decimal. It's 6.349. So it's not a whole number. So that kind of gives us a bummer. It also shows that it's not going to be B because that has 16. So we know it's not B. So now I'm down to A, C, or D. So the nice thing is I see that I have 4 and a 4 underneath my root. Okay, so we know for sure I can take a 4 out. But what is 256 divided by 4? So I look at that and I say, all right, let's see. So 256 divided by 4 is 64. And we know that the third root of 64, Actually, you know what? Desmos is nice. It lets me actually do third roots. So I'll show you. Third root of 64 is 4, which is nice because we had 4s all the way. So this was 64, right? And so when I take the third root of them, right, third root of both, I'm left with 4 and then the third root of 4. Okay, so that's for my 256. Now let's break up t to the 4/3. Well, another way to write this would be just t to the 3/3, right? 3/3, and then t to the 1/3, right? Well, t to the 3/3 is just going to be t, and t to the 1/3 is going to be the third root of t, right? So combining what we have, we can actually see that we have 4t, right? And then we have the third root of 4 and the third root of t, so it'd be the third root of 4t. And so we look, and obviously it's not going to be d because that's a square root. And so we look and we actually have two options. We have A or C. Now, the technical correct answer for this one is C. The reason it's C is because we don't know whether t is going to be positive or negative. If t was positive, t is positive, then we'd get a positive, we'd get something that looks like A. But if t is negative, we would have to have a negative version of that. And remember, we can get negative third roots. So in one of our previous problems, it says that x was positive. That's because we were looking at an even-powered radical. And this one, we're looking at odd, so you can get negatives, and it's not imaginary numbers. So the correct answer is C. If you put A, you're not wrong. You just kind of forgot the part about T. Now, on your test, I'll be a little bit more lenient on that because that's kind of a tricky thing that gets glossed over quite a bit. All right, let's look at question number 7. It says, the velocity v of an object can be defined as v equals the square root of 2k over m, where m is mass and k is kinetic energy. So what we're asked to do is find the velocity of an object who has a mass of 20 grams, so that's our m, okay, and a kinetic energy of 360, which is our k, right? So all I'm going to do is I'm going to say v is equal to the square root of 2 times 360, because that's our kinetic energy, divided by our mass, which is 20 grams. So the cool thing is we can actually just go right to Desmos, and we can put this right in, right? We can say the square root of 2 times 360 divided by 20. And check it out. We get 6. That's our correct answer. So we know that this is just going to be 6, and our correct answer is going to be A. So hopefully you got that one right. Now, number 8, it says a correct step of the solution of this equation is what? So they're not asking us to solve for z. We don't really care what z is. In fact, we're just asked to solve it out and to see which one of A, B, C, or D is a correct step in our solution. So I'm going to just start solving it and see which one shows up. So I'll start by writing 5z minus 1 to the 1/3 power, okay, minus 3 equals 1. All right. You know what? I'm going to get rid of some of this right here. Okay. So if I'm going to solve that out, the first thing I have to do is I have to get rid of this minus 3. So I'm going to add 3 to both sides of my equal sign. And I get 5z minus 1 to the 1/3 is equal to 4. Now, is that one of our options, A, B, C, or D? At this time, it is not, okay? So what we're going to do is we're going to keep moving, okay? We keep trying along. So we take this, and I get rid of the 1/3 by doing it to the 3rd power, right? So 3 and 1/3, those go away. I get 5z minus 1 is equal to 4 to the 3rd. Well, we kind of did that problem earlier. We can look at it in Desmos in case we forgot. 4 to the 3rd is 64, right? And so we say is equal to 64. And now I look and I see that that actually is D. That's step D. So D is the correct answer for number 8. We're not asked to find Z, but if we were, okay, if we were asked to do that, we would just add 1. We'd add 1. We'd get 5Z is equal to 65. 65, excuse me. And then Z would be equal to 13. That's what z equals, okay? All right. Number 9, we're asked to simplify this square root. Now, this is where it's important, again, when we have square roots, to have absolute values or positive negatives, right? Okay, so square root, all right? So I'm just going to rewrite this as 25 p to the 4th t to the 2nd to the 1/2 power. Now, I have to distribute my 1/2 to 25, to p to the 4th, and to t. And so hopefully you know that 25 to the 1/2 power is 5. Square root of 25 is 5. So p to the 4th to the 1/2 would be 4/2, which would be p to the 2nd. And we'd also want t to the 1/2, or 2 times 1/2 would be t to the 1. So our correct answer for this is 5p squared t. Now, obviously, since it's a square root, we cannot get negatives to come out, so it's not going to be c. One thing that we'd want to make sure, okay, so obviously square root of 25 is 5, okay? Now, p, it wouldn't matter if p was positive or negative, right? Because anytime you square a positive or a negative number, it becomes positive. Where it does matter is if t is positive or negative. So the correct answer for this one is D. However, if you would have put B, you probably would have got it right on the test because, again, that's something that gets glossed over and something that is tricky for anyone to really think about and to get that right. But for sure, A is not correct, right? But B or D would have been fine. All right, last question we're going to look at. Okay, we're asked to simplify the square root of 32 minus the square root of 18 plus 54 plus the square root of 150. Okay, so first thing I have to do is I have to break each one of these down into something that I can actually take and add or subtract together because they're all different numbers under the radicals. Now, first, let's look at the square root of 32. Now, the square root of 32 is, I do know the biggest square root I can take out is 16 and times 2. So the square root of 16 and the square root of 2. Square root of 16 is 4, and the square root of 2 is just square roots of 2. Okay, so that's the first one. Let's look at the next one. Okay, square root of 18. Well, that's going to be 9 and 2. Square root of 9 is 3. Square root of 2 is just square root of 2, right? Okay. So that would be square root of 2. And then the next one we have is, let's see, I guess I'll do it in green. Square root of 54. Okay, now I can't break that down into a 2 because that'd be 27, and that's not a perfect square. But the biggest perfect square I can take out is 9 and 6. So the square root of 9 is 3, and the square root of 6 is just square roots of 6. And then finally, the last one is the square root of 150. And that's going to be, well, 15 and 10, but neither one of those is a perfect square. So if I was going to say 6 out of that, because I see a 6 right there, I would say that this would be actually 25 and 6, right? And so the square root of 25 is 5, and the square root of 6 is square root of 6, right? So what I'm going to do is, with all of these, is I'm just going to replace each one with our broken down simplified root, right? So it's going to be 4 square roots of 2 minus 3 square roots of 2. And then we have plus 3 square roots of 6. And then plus 5 square roots of 6. And so just like with variables, radicals are like, we can combine like terms. So 4 square roots of 2 minus 3 square roots of 2 is just 1 square root of 2. And then 3 square roots of 6 plus 5 square roots of 6 would be 8 square roots of 6. And this actually doesn't simplify any further, so this is our correct answer. And you probably noticed that that's not an option here on number 10, but it was on the video question. So hopefully you got that one right. So hopefully this made it a little bit easier. If any of these 10 questions were an issue, or you're confused at what was asked, or you want to know more about those absolute values or positive or negatives when it comes to simplifying roots, make sure you save those for our Zoom session on Thursday. And you can ask those for sure, and we can go over more problems like them so you feel more confident for your test on Friday. All right. Well, have a great rest of your day. Good luck, and we'll see you tomorrow.